Intersecting chord theorems. Okay, we have a circle here, and the line AB is a chord, and the line DC is a chord, and those chords are intersecting inside the circle. So when this happens, AP times PB is always equal to DP times PC. So let's say we had 2 and 12 here, and 6 and 4 here. So AP times PB, 6 times 4 is 24, and that's the same as 2 times 12, which is 24. Okay, that always happens when you have chords intersecting inside a circle. Now, so I suggest if you ever meet these questions in your exam, you remember that formula and you, if necessary, relabel your points. So we always call that P, and then each side of your chord A and B, and a other chord C and D. So we know our intersecting chord theorem, AP times PB is equal to CP times PD. So we can use that to work out our unknown length here. AP is X, PB is 3, CP 9, PD 4. So 3x is equal to 36. Divide both sides by 3, x is 12. Now, what happens, well, we've got some chords here, they're not intersecting. If I continue them on, they will intersect outside of the circle. So as before, we can use the same formula. Again, if I always label the bit where your chords meet as P, AP times PB is equal to CP times PD. It's a little bit different with this one because it's that whole length there multiplied by that small length is equal to that whole length multiplied by that small length. But if you always label your intersecting part P and then each side of your chord on your circle A, B, C, D, we can always use that same formula. And here we go, here it is again. Right, so let's just apply that. So P is where the chords intersect. So they can intersect outside your circle or inside your circle. And we'll have AB and we'll have CD. So we know that AP times PB is equal to CP times PD. AP is 8 because we've got 3 plus 5. And PB is 5. CP. Now CP is X plus 4. And PD is 4. Let me just simplify here. 40. And I'm just going to bring my 4 outside my brackets and expand the brackets. 40 is equal to 4x plus 16. Multiply everything by 4 there. So let's solve this equation to find x. Let's take 16 off both sides and divide both sides by 4. So x is 6. Okay, so have a look at this example. Find the missing length DP. Let me just put all this information onto my diagram. AP is 4, PB is 3, CD, so the whole thing there is 8, which means DP is X, 8 minus X. Right, okay, let's just start that again. We know the whole CD is 8. We don't know DP, so I'm going to call it X. And then CP would be 8 minus X, right? Because it's 8 minus X. Let's put everything into my formula. AP times PB is equal to CP times PD. So 4 times 3 is equal to CP is 8 minus X times X. Just make sure you have your brackets around your 8 minus X. So let me just kind of rearrange this a bit. Expand my brackets. Ooh, we have a quadratic equation. Quadratic equation needs to be equal to 0. We want a positive x squared. So I'm going to bring everything over to my left-hand side by adding x squared to both sides. And I'm going to minus 8x off both sides. The reason I didn't take everything to the right there is because I would have had a negative x squared. Don't want a negative x squared. Okay, so let's factorise. So 2 numbers times to get 12 and add to get negative 8. No, other way around. Minus 6 and minus 2. Negative 2 times negative 6 is 12. Negative 6 add negative 2 is negative 8. Solve. X is 6 or X is 2. So here, PD would be 2. CD, CP would be 6. So it could be either, could be X, could be 6 or 2 there. So you could have, it just looks like that's the bigger length there, 6 and 2. Okay, have a go at these 6 questions. Put me on pause and pause when you're done. Okay, so I might pop these across 2 pages. Let's look at the first 2 on this, first 3 on this page and the other 3 on the next page. So we'll have P, A, B, C, D. I'm going to pop my formula here. AP times PB is equal to CP times PD. Right, so let's look at question 1. AP is 12, PB is 8, CP is X, PD is 4. We've got 96 is equal to 4x. Divide both sides by 4, gives you 96 is 24. No, gives you x is 24. Question 2. Let's just label. AP is 3, PB is x, CP is 5, PD is 15. So we have 3x is equal to 75. Divide both sides by 3, x is 25. Not sure if you've noticed this in the question, but that 5 is randomly down here, should be up there. Okay, so P, A, B, C, D. So 7 times x is equal to 5 times 14. 7x is equal to 70. Divide both sides by 7. X is 10. Okay, 4, 5 and 6. So for 4, P, A, B, C, D. So we have x times 12 is equal to 9 times 6. 12x is equal to 54. Divide both sides by 12 gives us x is equal to 4.5. Question 5. So 2x times 18 is equal to x plus 4 times by 6. So we'd have 36x is equal to 6 bracket x plus 4. Let's just expand the brackets here. Subtract 6x off both sides and divide both sides by 24 gives us x is equal to 1.25. Not sure if you've noticed this in the question, but that 5 is randomly down here, should be up there. Okay, so P, A, B, C, D. So 7 times x is equal to 5 times 14. 7x is equal to 70. Divide both sides by 7. X is 10. Okay, 4, 5 and 6. So for 4, P, A, B, C, D. So we have x times 12 is equal to 9 times 6. 12x is equal to 54. Divide both sides by 12 gives us x is equal to 4.5. Question 5. So 2x times 18 is equal to x plus 4 times by 6. So we'd have 36x is equal to 6 bracket x plus 4. Let's just expand the brackets here. Subtract 6x off both sides. Divide both sides by 30. So 24 divided by 30 gives us x 0.8. And number 6, x times x. So let's just label up. We've got P, A, B, C, D. So we have x times x is equal to 5 times 20. X squared is equal to 100. Quadratic, so let's subtract 100 from both sides. Difference of two squares, x plus 10, x minus 10. So x is equal to 10 or negative 10. Got to be 10 though, can't have a negative dimension. Okay, have a go at these 3 and the next 2 when you're ready. Put me on pause and pause where you did. So there's my P. We've got A, B, C, D. So for 1, 4 times 9 is equal to x times x. 36 is equal to x squared. Take 36 from both sides. Factorise. Solve. Has to be a positive dimension. Let's label up. 8 times x is equal to 4 times 9 minus x. We've got 8x is equal to 36 minus 4x. Let's add 4x to both sides. Divide both sides by 12. Gives us x is 3. And the last one here, well, actually you've got 3 more. Last one on this page. 4 times 18 is equal to x times x plus 1. So we have 72 is equal to x squared plus x. Let's take 72 off both sides. And let's factorise. So times to get negative 72. Add to get 1. So you've got 1x. We have minus 9. Nope. Positive 9 and negative 8. Because 9 times negative 8 is negative 72. 9 add negative 8 is 1. So x is either equal to minus 9 or x is equal to 8. It's got to be 8. Can't have a negative dimension. Finally got one intersecting outside. So that's our point P. And then we've got A, B, C, D. I think you know your formula by now. Let's just write it down anyway. AP times PB is equal to CP times PD. AP is x. PB is 5 plus x. CP is 3. PD is 9 plus 3, which is 12. Expand your brackets. 5x plus x squared is equal to 36. Now, let me just rearrange this order on the left-hand side, and I'm going to subtract 36 from both sides. Let's factorise. Times to get negative 36. Add to get 5. That would be 9 and negative 4. So x plus 9, x minus 4, x is equal to negative 9, or x is equal to 4. X must equal 4, positive dimension. Okay, last one. Okay, they're the same. Let's just call them y, shall we? So we have 5y x times y equals 5 times y. Oh, I didn't really need to do that. Can we see that working out x, aren't we? Sorry, I thought we were working out the length of this line, which we're not, and we don't know. X has got to equal 5 if those are the same. Okay, let's just have a look at some exam questions. Find the value of x. So I'm going to label that P. We've got AP, CD, that's fine. AP times PB is equal to CP times PD. Right. AP is 5, PB is 9, CP is 6, PD is X. 45 is equal to 6X. Divide both sides by 6, gives us X is 7.5. And question 20. Again, I'm going to relabel this as P. So we've got A, aha. I'm going to also relabel these as B and C. AP times PB is equal to CP times PD. AP is 4 plus X. PB is 4. CP is 14 and PD is 3. 42. Expand our brackets. Okay, let's solve to find X by taking 16 off both sides. Dividing both sides by 4. Okay, last question here. Work out the value of X. Okay, so we know this topic is intersecting chord theorems. Do we have any intersecting chords? Well, we've got AB here crossing DO, but DO isn't a chord, is it? It's a radius. So let's extend that here. Now, I'm just going to bring it out and relabel it. I think it might help. So we've got AB and CD, let's say. Let's say they meet a P. So P is my F. I can leave AB as it is and CD as it is. Got 2, 7, 4. It's this length here I want to work out X. So our intersecting chord theorems, AP times PB is equal to CP times PD. AP is 7, PB is 4, CP is 2. No, CP is X and PD is 2. So you've got 28 is equal to 2X. Divide both sides by 2. X is 14. Now, the whole length is 14. So 14, no, it isn't. It's just X is 14. So from here to there is 14. I want to use that to work out the radius, you see. So X is 14. So we know the whole length, CD, is 16, because it's 14 plus 2. So the whole length, CD, is 16. So if we look back to here then, the whole length is 16, the radius has to be 8, right? So from 0 to here is 8. That radius is 8. Okay, then let's use that, because if we extend the line here, we get intersecting chord theorems, the intersection outside the circle. Right, so let's just have a look at that one. Let me just draw it out separately and I can label it myself. So I'm going to label that P, A, B and C, D. So I use that same formula here. AP times PP PB equals CP times PD. What do I know? AB is 11, 7 plus 4. PB is 5. I've just changed that to be a P. Right, now CD, so my CD here is that line there, which is 16. I don't want CD, do I? Well, yes, let's put it in actually. Let's put it in 16. And D to P is X. That length from here to here is X. Right, let's put it into the formula now. AP is 16 times PB is 5 is equal to PD, nope, CP, which is 16 plus X, times PD, which is X. So we've got 80 is equal to 16x plus x squared. Let's rearrange this, bring the 80 over to the other side by subtracting 80 from both sides. And let's rearrange slightly. So we've got 0 equals x squared plus 16x minus 80. Let's factorise. So we want two numbers that multiply to give us negative 80 and add to give us 16. So 20 and 4, what about minus? No, positive 20 and negative 4. So x is equal to negative 20 or x is 4. X has to be positive, so x is equal to 4.